In our previous examples, when we've been rearranging equations, we've only had to deal either with addition or subtraction or multiplication and division. We're going to look now at some strategies when we have to combine those two modes of isolating a variable. In this example, we have a rectangular shed, and we know the perimeter is 24 feet. We know the width of the shed is 4 feet, and we want to find the length. From your formula sheet, the perimeter for a rectangle is 2 times the length plus 2 times the width. Again, I know the perimeter, I know the width, and I want to find the length. So I'll substitute in what I know. The perimeter is 24 feet equals 2 times our unknown length plus 2 times our width of 4 feet. Our goal remains the same, to get this variable L isolated or by itself by moving all of the other pieces of the equation to the other side. I'll make this a little easier by doing this multiplication now. So I get 24 equals 2 times L plus 2 times 4 is 8. I need to move both this plus 8 to the other side of equation as well as this multiplication by 2. It's easiest to move any terms that are being added or subtracted first. So 24, when I move this plus 8 to the other side, it becomes the opposite operation, minus 8 equals 2 times L. Again, I'll simplify by doing this subtraction, which gives me 16 equals 2 times L. And now to get the L by itself, since it's being multiplied by 2 right now, I can divide by 2 on the other side of the equation. 16 divided by 2 equals L, or L equals 8. My units are feet. So we used the same strategies we did in the previous videos. In this case, we just had multiple operations combined in one equation. We moved the terms that were being added or subtracted first, and then did any multiplication or division. You can see this added to our general rules. So as we know, to move something to the other side of the equal sign, we do the opposite operation. And now we've seen that it's easiest to move terms that are being added or subtracted first, and then we can move any coefficients, or the numbers being multiplied by our variable, using multiplication or division. You may have noticed in our examples so far that our units have always matched, so we haven't had to worry about that. As a reminder, make sure that your units match, so we're dealing, for example, all in feet or all in meters, before you start doing this algebra. We'll look at that in the next question. Here we have a rectangle with a perimeter of 13.2 meters, and we know the length is 5.5 feet. We again want to find the width. We'll report our answer in meters to 1 decimal place. I can't do the algebra yet because my units don't match. I have perimeter in meters and length in feet. Since I want my final answer to be in meters, I'm going to convert this 5.5 feet to meters. As a reminder of the conversion, I start with the value I was given, 5.5 feet, and I know the unit conversion between feet and meters, so I can set up my fraction. I want to cancel out the units of feet, so that will go on the bottom. I want to get to meters, so that will go on the top. From this conversion, 1 foot is 0.3048 meters. You can do the multiplication, and 5.5 feet is equal to 1.6764 meters. This is the value I'll use in my algebra calculation for the length, and the perimeter is already in meters, 13.2. From here, I'll carry on like I did above. Perimeter of the rectangle is 2 times the length plus 2 times the width. I'll substitute in what I know, 13.2 for the perimeter, 2 times my length in meters, 1.6764, plus 2 times the width. Pause the video for a moment and carry on from here to find the width by yourself and round your final answer to 1 decimal place. You can see that following through the same steps here, I moved the term that was being added first by subtracting it on the opposite side of the equation, and then I moved this coefficient, or the number being multiplied by our variable, using division, to isolate the variable w, or get it by itself, and find the width of 4.9 meters.